This is lesson 3.4. Right now, students are working on the warm-up. They're trying to determine whether lines AB and CD with the given coordinates would be parallel, perpendicular, or neither. My hint to them was start with finding slopes. Here's our slope formula. The rate of change in y over change in x. The difference of your y coordinates will give you the rise. Difference in the x coordinate will give you a run. Slope is our ratio of our rise to our run. If it helps you to label coordinates like so, you can do that. Okay, keep working if you're not done. I'm going to start writing these up here. Okay, hopefully that kind of gave everybody enough time to try these. Number 3 is an interesting one. Let's start with number 1. Okay, so I always keep it consistent. Call my first one x1, y1, second one x2, y2. Good stuff. With me, Alejandro? Yes. Okay, so here I got 2 over 8, which can be reduced to 1 over 4. That one you should get a positive 1/4 for the slope. You got that? Nice job. CD, line CD, I got 12 over negative 3, which reduces to negative 4, or you can write that as a fraction if you want to, negative 4 over 1. In order for lines to be parallel, what has to be true about their slopes? You just shout it out. Same, right? The slopes have to be the same. Are these the same? No. Okay, so not parallel. Perpendicular, 2 differences. Raise your hand who can give me 1 difference. Ben.
Oh, it has to be reciprocal.
Beautiful. The numbers have to be reciprocals of each other. What's the other characteristic? Lillian?
One has to be negative.
One has to be negative, one has to be positive. They have to be opposites. Do we have opposites here? We have 1 positive, 1 negative. Yes. Okay, fits Lillian's criteria. Are they reciprocals? Yes. Fits Ben's criteria. They have to fit both. These are perpendicular. Raise your hand if you got that right. Nice. Okay, number 2. Here I got negative 8. Oh, I'm sorry. Negative 3 minus negative 8, which turns into positive 5. Careful with all the negatives. 4 minus negative 1 is 5. You should have gotten a slope of 1 for line AB. CD, 9 minus 1 is 8. 5 minus negative 3 is 8. I also get a slope of 1. And since these are the same, these you should have gotten parallel. They both have a ratio of 1 for their rise to their run. I love number 3. So fun. Something interesting happens. We get 4 over 0. Have you ever seen those math posters where it's like, no, we can't divide by 0? What does that mean for our slope? undefined. If you try to type this in your calculator, it's going to say error. Undefined. Show me with your arms. What kind of line is that? Vertical line. Remember slope, dude? Undefined. You fell off the cliff.
That's the worst.
Okay. Here we get 9 minus 9 is 0, negative 10 minus 1, 0 over negative 11. So if you've ever seen those math posters, like, this is okay. Type this in your calculator, it's going to tell you it's 0. Show me with your arms what type of line that is. Yes. Horizontal. So it's not tricky, but these are technically perpendicular. Right? If you had a perfectly vertical and a perfectly horizontal line, wouldn't those cross at a right angle? So it's just a weird case scenario. It doesn't really fit the opposite reciprocal kind of criteria, but these are perpendicular. Did anybody get that right? Good job, ladies. Okay. There's a little review over slopes. So I just collected your 3-3 worksheet. 3-3 book is your homework for tonight. All right. This lesson is called Equations of Lines, and it's more review from Algebra 1. Okay? It's kind of fun, writing equations of lines. So let's review over what we need to know before you can write or graph an equation of a line. There's kind of like two cases scenario. And we can kind of connect this with what we've learned within geometry. We had that postulate that said, if I have 2 points, there is exactly one line that goes through the 2 points. So if we're given 2 points, there's only one line that goes through those, and we'd be able to calculate the equation of that line. Okay? Maybe sometimes we're only given 1 point, but maybe we're given the rate of change, which is our slope. In that case scenario, we could write the equation of the line, or we could graph it. Or in this case scenario, we could also write the equation of the line. So with a lot of these problems, guys, that's kind of how it's set up, is they'll give you 2 points, even word problems, or they'll give you a point in the slope, and then from there, we use kind of like our different forms of equations of lines to write the equation of the line. Here's our most common classic way to write an equation of a line, slope-intercept form. I'm sure this is engraved into your brain. Y equals mx plus b. Remember that? Okay. The reason why this is called slope-intercept form is because I can tell just by looking at the equation, I can tell what the slope is. It's the coefficient in front of the x. That's the slope. Okay, they're showing you that over here too. M is our slope. We talked about why M is used for slope. It comes from that French verb. And this constant here, the one without the x, that's my y-intercept of the line. And that's what they're showing you right here. On a graph, who can tell me? Raise your hand. On a graph, what is a y-intercept? Raise your hand. Walker, you got it?
Whatever that's called.
Okay, you're right. The y-axis. Alejandro, add to that.
Where the line is the y-axis is 0.
Exactly, where the line crosses the y-axis. Okay. So in this example, if I y equals 3x plus 8, 3 would be my slope. Let me get my colors consistent. 3 would be the slope. That would be my ratio. That would be my rise to the run. It would cross the y-axis at 8. 8 would be my y-intercept. Do you guys know why they use b for y-intercept? Want to know another fun fact?
Give us a fun fact.
It's not as fun as slope. It doesn't come from like a cool word, but it's still cool. It's still useless knowledge. Okay,
Oh.
just kidding. When you get older, you will graph things like this that we call like they're polynomial functions. This one we call degree 3. Anyways, what we use in like standard form for all of these is we always just start with A and do an alphabetical order from left to right. So you say like A is the coefficient, B, C, and then D would like be my constant if I had a degree 3. Okay, so lines are degree 1 because they only contain an x. They only contain an x. They don't have an x squared or anything like that. So normally with polynomials we would say A and we call the constant B. But because we have a special name for slope, they just replaced this A with M, then they decided to leave the B and said, we'll just keep it in standard form for the rest. That's why I told you it wasn't as cool, but it's still fun. Okay, slope-intercept form, good times. This one perhaps maybe we'll take a little dusting off some wheels back here. Point-slope form. So we use this one if we know a random point on the line that's not the y-intercept, and we know the slope, hence the name point-slope form. This one, y minus, you do this in algebra, y1 equals m parenthesis x minus x1. There is a little sub 1 right here. It's hard to see. Sub 1, x sub 1. Okay. Do you guys remember this one? Okay, cool. M is still our slope. Special letter. That's still our slope. And what's cool about this one is you can use any point on the line. And that's what x1 and y1 represent. They represent a point. I'm trying to get my red marker. Red marker doesn't work. X1 or y1 is a point. Any point on the line. Okay, write that down. Here we go. Any point on line. So over here, you can see like x1 is 3 and y1 is 5, and the formula is x minus and y minus. So the 0.35 would be on our line. And then obviously right here is still my slope. All right, before we move on, y-intercepts can be written as a point. In order to have a y-intercept or an ordered pair parked right on your y-axis, the x value would always have to be 0. Okay, picture this if I pulled up a coordinate plane here. The only way I could have a point that crosses is if the ordered pair was 0, comma something, right? So your y-intercept as an ordered pair might show up like this. If you see 0, comma negative 3, hey, you're actually given the y-intercept, even though that doesn't say my y-intercept is negative 3. All right, there's your review. Let's try some practice problems. All right, this first one we have here says, write an equation in slope-intercept form of the line with a slope of 6 and a y-intercept of negative 3. Then graph the line. All right, they tell me my slope is 6, and they tell me my y-intercept is negative 3. So I like to use b because that's what is used in my formula. Negative 3. So I was going to ask students to go through like this checklist in your head. Are you given the slope? Yes. Are we given the y-intercept? Yes. So that means we're going to use slope-intercept form to write this. And from there, all you got to do is plug in your slope, which is 6. You always leave x and y in the equation when you're writing equations of lines. It should always have x and y in it. And you plug in negative 3 for b. You can either do -3. If you want to do plus -3, that means the same thing. That right there, folks, that would be the equation of the line. Okay? So y-intercept of -3. When we go to graph this, and remember how you graph lines, you start with the y-intercept. You start here. We find -3 on the y-axis, and you put a point there. Okay, if it helps you to think of it as an ordered pair, that's really the point. It's your -3. Now I know my rate of change is positive 6/1. So you put your pencil here. Since it went positive, I'm going to go up 6. Think of 6 as a fraction. Over to the right, 1. It really technically only takes 2 points to draw a line, but the more points you can do, the more accurate this is. You're going to want to use a straight edge. You can also go down and left. I always tell my students, make sure when you graph your line, we obviously have a positive slope here. So when you go to connect your dots from left to right, your graph should be rising. So a lot of times students will forget, oh, do I go up and left? Do I go down and right? Sometimes that can be confusing. Just graph your slope and then ask yourself, does my graph make sense? Would my slope dude be going puff, puff, positive up this hill? Yeah, that's a pretty steep hill too. And remember, the bigger that rate of change is, the steeper your line will be. Okay. That was level 1. Level 2. Right, an equation in point-slope form this time of the line passing through the point -1/6 with a slope of 1/7. Am I given my slope? Yes, my slope is 1/7. Am I given my y-intercept? No. That point is not my y-intercept because my x-coordinate is not 0. So it's just a random point on my line. So we're going to use point slope form, and I'm going to actually write it out because that helps you memorize it. Y minus y1 equals m parentheses x minus x1. Plug in your slope. We know our slope is 1/7. All right, now, just like before, you always leave the x and the y, and the x sub 1, y sub 1, that's talking about the point. So then you plug in the point. X sub 1 is -1. That goes near the x. Y sub 1 is 6. That goes by the y. Now they want me to leave this in point slope form. So the only thing I'd maybe do to clean this up is change that minus and negative to a plus positive. And there is technically that equation in point slope form. Which feels kind of weird because we're used to putting things in slope intercept form, and we'll get there. But pay attention to what form they want you to leave it in. Okay? Any questions on level 2? Ready for level 3? Okay. Write an equation in slope intercept form of the line which passes through the points 2, 5, and -7, 1. Am I given the slope? No. No, I'm not given the slope. But I can find it, right? I'm given 2 points. Slope formula. y2 minus y1 over x2 minus x1. Okay. Let's do it. y1 is 1 minus, y2 is 1 minus y1 is 5 over x2, -7 minus x1, which is 2. 1 minus 5 is -4. -7 minus 2 is -9. Ooh. Negative over a negative reduces to positive. 4 nines doesn't reduce. They don't have any common factors. 4 nines is my slope. Am I given the y-intercept? No, I'm not. Neither of these points have 0 as an x-coordinate. But they want me to write it in slope-intercept form. So I'm going to have to kind of take an extra step. I'm going to have to use point-slope form. because I know a point, and now I know the slope. The slope is 4/9. And then you can use either point on your graph. I'm going to use the 0.25 because those are nice numbers. There's no negatives or anything like that. And we get to here. Is this equation in y equals mx plus b form? No. But we can do that. It's just a little bit algebra. All you got to do is distribute the 4/9. Ooh, fraction. 2/1, that'd be 8/9. And then all you got to do is add over the 5. Okay, 5/1, think of that as 45/9. So 45 and negative 8/9 would be 37/9. Yep, that's it. I do want to mention that sometimes you might have learned to plug the slope in and then plug in your point this way and like solve for your b. And that works. But this equation is used a lot in future math classes, so it's good to start to know it now. Okay? This is fine. I'm just not a big fan of this because your future holds this in it a lot. So let's get used to using it now. Okay. Woo. Nasty y-intercept. What is the y-intercept here?
6.
No. 6.
37.
37/9.
Oh, okay. Of course.
Now that we're in y equals mx plus b. The slope intercept would be 37/9. Okay. Now, this is a great example of when we can just jump to slope intercept form. And when, look at the second graph, can I clearly tell where that crosses my y-axis? No, it looks like it's like maybe 3 3/4, but I'm just guessing. All right. This one, I'm like, hey, I can see what my y-intercept. My y-intercept is clearly 6. Now, am I given my slope on these? No, they don't tell me, but I can figure out what it is, right? We can just count our rise over run, so we just got to find 2 points. We'll use that y-intercept and maybe this one. Now, careful here. We are counting up by 2s. And I see my rise is 4. My run is 6. It's positive, so I'm going to keep it as positive 2/3. If I reduce that. All right, now for this one, I can jump right to slope-intercept form because now I know my slope. I just had to do a little bit of math. And I know the y-intercept is 6, so it'd just be plus 6. And that right there, folks, is the equation of that line. Notice in the direction, it didn't tell us to write it in slope-intercept form. It just said write the equation of a line. If you ever see that, assume they want slope-intercept. Okay, assume that they want this because that's the most common one. All right, this one. I don't know the y-intercept. I can see there's 2 points clearly labeled here, so I can count the slope. Don't forget this one is a negative sloping line. So my rise is 1, run is 3. All right, and then you can use either point to use with the point slope form. I'm going to use this one. That's the ordered pair 2, 3. So everything's nice and positive. 2, 3. And then off to the left here, I'm going to have to do point slope form. All right. So, negative 1/3 is my slope. Leave the x and y. x1, y1, that's my point. So x1 would be 2. Y1 would be 3. And then we're going to write this in slope-intercept form. But I had to start in point slope form because I don't know what the y-intercept is. All right, this is good distributive practice, negative 1/3 x. Negative 1/3 times negative 2 over 1 would be positive 2 over 3. I need to add 3. All right, so think of that as 9/3. We get 11/3. What is 11/3 as a mixed number? Ben?
3 2/3.
Good. Does that look like it'd be crossing at about 3 2/3?
Yeah.
Yes. Okay, you should be checking those things to making sure your answer makes sense. I got y-intercept to 3 2/3. I think I had guessed 3 3/4, and I was like, yeah, about 3 3/4. That's pretty close. 3 2/3. My slope is negative. My line's going down. Nice, negative. Slope would be going downhill. Okay, I forgot what level we're on.
4.
Level 4?
Question mark?
Okay.
Challenge question.
We have a couple special types of lines, and we've already talked about their slopes, but we haven't talked about their equations. Okay? If I have a horizontal line, like this one, horizontal lines have slopes of 0. So if I were to write this in slope-intercept form, I'm going to have 0 times x, so I'm just left with y equals b. Y equals some y-intercept. So y equals negative 3. I go to my y-axis, I find negative 3. It's just a horizontal line because every single y-coordinate of every single point on that line is always negative 3. Okay? X equals a little bit harder to derive from slope-intercept form because it has that undefined slope. So think about what I just said with a horizontal line and connect it with a vertical line. On this line right here, every single x-coordinate is constantly what number? Negative 2. So that equation, anytime you see x equals some constant, that's a vertical line. Got it? You've graphed those before in Algebra 1, right? Okay, beautiful. So let's try an example here. Write the equation of the line passing through the points. Obviously not given the slope. We can calculate it. Let's go ahead. y2, 6, minus y1, negative 1, over 2 minus 2. This one's kind of similar to that one in the warm-up where I get 7 over 0. Undefined slope. Good. Which means it's what type of line? Vertical. Yep, this way. When people like test your vertical, how high you can jump, right? Vertical. So vertical lines are always x equals some constant number. And look at your order pairs. What are both the x coordinates a constant number of? 2. So the equation of that line is always going to be x equals 2. And think about it. If you were to plot those points, folks, you don't have to do this. If you were to plot those points, this would make sense. I have 2, negative 1 is here. 2, 6 is here. So the one point, or the one line that goes through both points would be that vertical line where x is always 2. All right, let's pick our heads up off our desk, please. Thank you. All right, next one. 2 points. Let's calculate the slope. 4 minus 4. y2 minus y1. 8 minus negative 2. You get 0 over 10, which is 0. Which is what type of line? Horizontal.
Yours is different. We have a 10 on Y for us.
Oh, you do?
Yeah.
Oh, change it to a 4. Sorry, I must have forgot to do that before I made copies. Yeah, change that to a 4, otherwise it's not going to work. Thank you. I'll fix that. All right, horizontal line, which means it's always y equals some constant number. What's my constant number here now that you change that? 4 would be the equation of that line. Y equals 4. This is really easy. All right, what do we got for time? Let's stop there. That's where I stopped my other class. We have a few minutes. I can pass it over to you. We just have a couple word problems, couple more levels, but we will leave it off there. Finish up tomorrow.
I don't know. This whole chapter, man. I don't remember any of it.